So I am a Atracción de Talento researcher. I started to work here in the Universidad Autónoma since 2022, where basically my research line is going to be focused on quantum optics in the solid state at the experimental level, as you can see. I finished my PhD in 2015 here as well in the Universidad Autónoma, where I was working on quantum fluids of light using semiconductor materials. Then in 2015, I moved to France, where I stayed for 5 years, working in the French National Research Council in the group of CENELART, working this time on quantum optics with semiconductor quantum dots. So from there, in 2019, I moved to Germany, where I stayed for 2 years and a half. In the first period, I was in the University of Würzburg, and secondly in the University of Oldenburg, working with Professor Schneider. And basically during this time, my main research line was on two-dimensional materials and how they can couple to light, and also as well seek for different applications such as ultra-thin lasers and also single photon emitters. And then finally in 2022 is when I took the decision to come back to Spain, developing and leading my own research line on quantum optics in the solid state, using different quantum materials to exploit their quantum emission of light for different applications, which is in connection as well with the Ramon Areces project that I will develop here in the university. So the project is focused in two main objectives. The first one is developing an ultra-bright source of single photons using different quantum materials that are coupled to a structure in which we are capable to confine light. So essentially, this device, what it does is to confine light between two mirrors. Then we insert our quantum material in between, and this system, the material that we are using, initially a two-dimensional material. In a second stage, it will be a different type of material, semiconductor quantum dots. What we can do is to enhance the optical properties of the material to emit light within this cavity and enhance the single photon emission. So this renders a single photon emission that is simultaneously very bright, very pure. Photons are emitted one by one, and also the emission of photons is highly indistinguishable, meaning that all the photons are the same, and so they are useful for different quantum optical applications, either computation or telecommunications. And on a second stage, the second objective will be to use this single photon emission for specific applications, such as, for example, multi-photon interference that is more related to quantum computation, or also as well other things more related to quantum communication, such as, for example, entanglement of states of single photons or teleportation of quantum states. And initially, the very first challenge is going to be dealing with the nanofabrication of this optical cavity where we have to confine light. This implies the development of the mirrors, which has some nanofabrication steps that will be a little bit complicated, and we have to learn how to do them properly. So the first challenge, of course, is going to be to have a high quality cavity for light that we can couple to the material, and then prove that the emission of single photons from this device is as we expect. And then, of course, on a later stage, the main challenge it will be to tailor correctly the properties of this single photon emission to the specific application that we will seek. This will come in a second stage. In a few years, I see myself leading an experimental research line on quantum optics within the IFIMAC, having the chance to collaborate with more people also within the institute, so that I can exchange knowledge and amplify the lines of research that I'm capable to do. So that would be my first objective, being able to collaborate with more people, both experimentalists and theoreticians. And secondly, I hope to see myself having demonstrated this super bright single photon emission with potential applications to other quantum phenomena. This is where I would like to see myself. Yeah.